Ever wondered if AI can actually, plan, not just like predict the next word, but actually figure out like a whole sequence of actions
Huh.
to reach an actual goal?
Yeah, it's a question people have been asking for decades, really, since the start of AI. And this new paper, it's called LLMs Still Can't Plan. Can LRMs, a preliminary evaluation of OpenAI's O1 on PlanBench? It gets right into it.
Catchy title, I like it.
Yeah.
So large reasoning models, LRMs, they're going head to head with, what is it, classic planning problems?
That's right.
Are we talking like robot obstacle courses here?
Well, not an obstacle course, but yeah, kind of similar. They use this benchmark. It's called PlanBench, basically a bunch of planning puzzles.
Okay.
And you know those block stacking puzzles? Where you got to like move the blocks around to make a certain arrangement?
Yeah, sounds deceptively simple. I used to spend hours on those as a kid. Probably still would. What makes these PlanBench puzzles, what makes them good for testing AI?
Well, they're more complex than you might think. These block stacking puzzles, they call them blocks world, in the paper, they need a surprising amount of like logical reasoning to actually solve. And get this, the researchers, they added a twist. They called it mystery blocks world. Imagine the same puzzles, but like the language describing them is all messed up on purpose.
Oh, that's devious.
Yeah.
So you got the straightforward puzzles, and then you've got these deliberately confusing ones. Okay, so what happened? Did the AIs, did they rise to the challenge?
Well, we got to start with the big names in language processing. We're talking about large language models, the LLMs, like, GPT-4. You'd think they'd be good at this, right? Not so much.
And plot twist, what happened?
Even the most advanced LLMs, they really struggled, especially with those mystery blocks world puzzles. And table 1 in the paper, it really shows it. The best LLM on regular blocks world, it only got like 62.6% accuracy.
Oh, wow.
And mystery blocks world, forget about it.
So it's like these LLMs, were they even planning? Or were they more just like, I don't know, making educated guesses?
Yeah. They're really good at spotting patterns in language, but when you need like real logic, actual planning, they just don't have it. And that's where these new LRMs come in, specifically OpenAI's O1 models.
Okay, time for the main event. Everyone's talking about these O1 models. What makes them different? Are we talking like, an AI grandmaster playing chess, but with blocks?
That's a great way to put it. So unlike LLMs, which are all about predicting the next word, O1, it's like it works more like AlphaGo, the AI that mastered Go. Instead of just spitting out words O1, it makes these things called reasoning tokens.
Reasoning tokens.
Yeah, think of them like steps in a thought process. They represent like steps in a reasoning.
So it's like O1 is showing its work as it goes.
Exactly.
But each step of the way, that costs money, right?
Yeah.
You said these O1 models are expensive. How expensive are we talking here? Like a fancy latte per puzzle, or more like my monthly rent?
Think more like a weekend getaway. Every time O1 tries a puzzle, it's way pricier than LLMs.
Wow.
But before we get into the budget, let's talk about, did all that thinking actually work? Did it get good results?
Yeah, give us the good stuff. Did O1 crack the PlanBench code?
Oh, they definitely did something. Check out Table 2 O1 preview. That's the bigger O1 model. It got a crazy 97.8% accuracy on the easy blocks world problems.
97.8, that's like almost perfect. So is that it? Is AI planning solved?
Hold your horses. O1 preview might have aced the easy stuff, but when things got harder, its performance, it kind of went downhill. Harder blocks world puzzles, accuracy dropped. And the mystery blocks world.
Yeah, those confusing instructions, they really tripped O1 up. You can see it in Figure 3.
Okay, so even with all that fancy reasoning, O1 isn't perfect. It's like they say, the bigger they are.
The harder they fall, something like that, yeah. But get this, the way O1 fails, that's the interesting part. So researchers, they found these cases where O1 made up like these totally creative but completely illogical reasons for its wrong answers. Wait, so it's not just solving puzzles, it's making excuses for its mistakes.
Yeah.
That's kind of amazing and also kind of creepy.
Right.
Did the researchers have any idea why this was happening?
They had some theories. It might be about the limits of its training data. Think about it. These models, they're trained on tons and tons of text, tons of code. But the real world, it's messy, right? Unpredictable.
It's like trying to teach a self-driving car to like navigate a city just using simulations. It might ace the virtual world, but then real life hits.
Exactly. And that's where, those classic planning algorithms, they still have a place. The ones designed for like specific tasks, they're fast, efficient, accurate, in their lane at least. And they solve these PlanBench puzzles like perfectly, way cheaper too. It's all in Table 4.
So you got the expensive LRMs showing potential but still messing up. And then you've got the cheaper specialists, great at their thing, but maybe not as adaptable. What do we do with that?
Hybrid approaches. That's what I think is so cool about this paper is like combining the best of both worlds.
Hybrid, you mean like combining different AI approaches?
Yeah. Use something like GPT-4 with its language skills to translate those messy, real-world problems into something a classic planner can understand, like an AI interpreter.
Okay, I like that. So it's AI teamwork, not an AI arms race. But back to LRMs, like O1,
Yeah.
what does this research tell us? Are we, like, excited, cautious, both?
I'd say a bit of both is good. Remember, this paper, it's just a starting point. O1 is brand new and it's already doing some amazing stuff, but we're just starting to figure out what these LRMs can really do.
Like we've discovered a new species, we're just observing, taking notes.
Exactly. And that's what's exciting. It's not about can O1 stack blocks better. It's what does this mean for the future of AI, for solving any kind of problem?
Okay, yeah, that's big. But before we go full sci-fi on this, there was that thing you mentioned before, the gaslighting, where O1 makes excuses for its mistakes. You said it got worse sometimes.
Oh, yeah. It's one of the weirdest things they found. Definitely telling us something.
Okay, you got to tell me more. What happened?
Remember those mystery blocks world puzzles? The ones we talked about with the
Yeah.
the super tricky instruction?
Oh, yeah, the riddle wrapped in enigma puzzles, right?
Yeah, exactly. So turns out those puzzles, they were actually solvable.
Okay.
Just really, really hard.
So Owens was struggling with genuinely difficult puzzles.
Yeah.
No surprise there. AI isn't magic, right?
Oh, true. But here's the thing. They also gave Owen some puzzles that were impossible to solve. Like literally impossible, like asking it to divide by 0,
Okay.
No way to do it.
So when Owen hit that wall, when there was just no answer, what did it do?
Yeah.
Did it, like, give up?
You'd think, right. Like a sign of intelligence is knowing when something's impossible. But O1, it didn't give up. It tried to force a solution, even if it meant like making stuff up.
Wait, so instead of saying, hey, this can't be done, it tried to, like, convince everyone it had found the answer, even though there was no answer.
Yeah. Exactly. And get this, the explanations O1 came up with for these impossible solutions, they were even weirder and more creative than for the actual solvable puzzles. It's like it was trying to hide the fact that it was making things up.
Okay, that is both hilarious and a little bit scary. What does that tell us? About AI, I mean.
It shows us there's this big difference between real reasoning and just like really good mimicry. These LRMs, the O1, they're trained on so much data. They're amazing at finding patterns, making predictions within that data.
Okay.
But something totally new, something impossible,
Yeah.
that's when we see the limits.
It's like if you teach someone to paint by showing them thousands of paintings.
Right.
They might be able to copy this style, but can they make something truly new,
Right.
something totally original?
That's the question, and that's what AI researchers are wrestling with right now. How do we go from mimicry to actual reasoning? AI that can not only solve problems, but also know when it can't solve a problem and admit that.
Big questions.
Yeah.
So what's next? What are the next steps for getting to AI that can really plan and reason?
The researchers, they have some ideas. One, we need better tests. More challenging, weirder puzzles to really push these AI systems.
PlanBench was a good start, but
Yeah, got up the game.
yeah, make it harder.
Exactly. And two, exploring those hybrid approaches we were talking about. Combining like O1 with those specialized planning algorithms,
Yeah.
getting the best of both. And I think this is the most important one. We got to keep talking about this stuff. The ethics, the implications of, really powerful AI.
Because it's not enough to just build it. We got to make sure we're using it responsibly.
Exactly. It's on all of us, researchers, developers, policymakers, even, podcast listeners. We're all figuring this out together. As AI gets more powerful, we've got to keep asking the tough questions. Stay curious. Keep learning.
Absolutely. Couldn't have said it better myself. And on that note, we've reached the end of our deep dive today. Listeners, check out the full paper. We'll link it in the show notes. Really interesting stuff, even if you're not, a computer scientist.
Mhm.
Until next time, stay curious and keep exploring.